In this question, in which ionic compound do the metal ion and the non-metal have the same electronic structure? Means they have the same number of electron in the atom or the ion, because they're forming ion. So what happened? Calcium oxide, if I say calcium oxide, so calcium, when we check calcium atom, it contains 20 electrons. And when we compare oxygen, it contains 8 electrons. When the reaction occurs between calcium and oxygen, calcium will lose 2 and oxygen will gain 2. So when calcium will lose 2, the calcium will have 18 electrons after the loss of 2, and oxygen will have 10 electrons. So they don't have the same electronic structure, because same electronic structure means they should have same number of electron in the ion. They don't have the same number of electrons. But when you check magnesium oxide, so magnesium with oxygen, when you check the number of electron, you have to use a periodic table. Magnesium atomic number is 12, so it contains 12 proton and 12 electrons. So there are 12 electrons in magnesium, and oxygen is having atomic number 8, so it contains 8 protons and 8 electrons when it is neutral. But when the reaction occur, magnesium loses 2 electron and oxygen gain 2 electron. So when the magnesium lost 2 electron, the charge on the magnesium will be 2 plus or plus 2. And how many electrons will be there in magnesium? It will have 10 electrons. Then what about oxygen? Because each oxygen gained 2 electrons, so how many electrons will be there on oxygen? 8 electrons. So now the number of the electrons are same for magnesium and oxygen. So if they have same number of electrons, these ions have the same number of electrons because they have same electronic structure. So means the number of the electron of magnesium ion are same as number of electrons present in the oxide ion. Or we can also use, sometime we can also use the term iso. Iso means same electronic. The term iso means same, like isomers, isomerism, isotopes. You use this word, so it refers to same. Is it clear? Question number 4 from page 2. Then page 5 question. Sorry, it was page 4. The magnesium react with sulfur to form ionic compound, magnesium sulfide. The diagram shows the electronic structure of atom of magnesium and sulfur. So magnesium is a group 2 metal, tend to lose all their valence electron. And non-metal complete the octet, means 8 electron in the outermost shell. So when these are the 2 electrons in magnesium outer shell, so it will lose both of the electrons to sulfur. So how many already 2 electrons in the first shell, that the second shell, how many electrons will be there? It will have 8 electrons. The last shell is empty because metal tend to lose all the valence electron to form a bond. And the charge will be 2 minus or minus 2. Sulfur gain 2 electrons, so 1, 2, 3, 4, 5, 6, 7, 8. This is the second shell. The third shell, which was already having 6 electrons, belongs to sulfur. Here the charge will be 2 plus or plus 2 because it lost electron, not minus. And sulfur, 6 electron belongs to sulfur. So it has 6 electrons and 2 it took from magnesium. So the charge will be minus 2 or 2 minus. Then ionic compounds such as magnesium sulfide do not conduct electricity in solid, but magnesium sulfide does not dissolve in water. Magnesium sulfide does conduct electricity in molten. State the condition needed for magnesium sulfide to conduct electricity. So what we should do, we should supply heat energy so that the state, or it will become molten magnesium sulfide, in which the ions will be free to move. In question 3, the aluminum oxide is an ionic compound with a high melting point. Complete a dot and cross diagram for one oxide ion present in aluminum oxide. So in practical, what happened? There are, when aluminum oxide is there, so when aluminum oxide is there, aluminum belongs to group 3 and oxygen belongs to group 6. If I'm drawing the valence or the last shell, so oxygen is having 6 electrons. And aluminum is having 3 electrons. So what happened? Non-metal always gain electron to complete octet, 8. So this aluminum lost 2 electrons and taken by oxygen. So this oxygen will take 2 and it will get -2 charge. Then 1 electron from aluminum, 1 and the second one, both are taken by this oxygen. So this will also get -2. And the last 2 electrons are taken by the oxygen as well. And it will get -2. And each aluminum charge should be 3 plus or plus 3. So in the question, they don't say draw the full aluminum oxide. They just mention draw one more oxygen ion or oxide ion in aluminum oxide. So here you have to draw oxygen belongs to group 6. So already 6 electron belongs to oxygen. And one of them took 2 electron from aluminum. So the charge will be -2 or 2 minus. Is it clear?
Yes.
So we have to draw only one oxide ion or oxygen ion instead of drawing the whole aluminum oxide. And the melting point of aluminum oxide is above 2000. So why high melting point? Because strong electrostatic force of attraction between the unlike charges or ions required greater amount of energy to separate. That's why it is having high melting point. Anyone else having a doubt in this ionic compound exercise? If you have a doubt, just send the doubt all together. So it will be convenient for me to discuss. The second one is covalent bonding, exercise of covalent bonding. Any one of you having a doubt in this? MCQs 10 and 16. The molecule of N2, C2H4, CO2 and CH3OH all have covalent bonds. These bonds consist of shared pair of electron. Which row give the total number of shared pair electron in the molecule? So you first, for this question, to answer this question, you have to draw the structure of each. First, we have to draw a structure of N2. Nitrogen belongs to group 5. If nitrogen belongs to group 5, so each nitrogen will share 3 electrons. So if each nitrogen is sharing 3 electrons, so how many electrons, the pair of electrons are there? 1, 2, and 3. Total number of shared pair. So how many pairs are there? 3, not 2. So this cannot be an answer. Because 2 electron refers to 1 pair. So this is 1 pair, 2, and 3. So 3 pairs are there, not 2. So this cannot be an answer. The second one, if we draw C2H4. So carbon belongs to group 4, it will share 4. And hydrogen belongs to group 1, so it will share 1. If hydrogen share 1, carbon will share 1 from that side. So first we start with hydrogen. Now sharing of hydrogen finished, but still carbon group 4, so it share 4. So remaining 2 it will share with another carbon. So how many pairs are there? 1, 2, 3, 4, 5, 6. So 6 pair of electrons are there which are shared. So B should be the right answer. Why not C? Because I will draw all. Why not C? Carbon dioxide, carbon belongs to group 4, it will share 4. Oxygen belongs to group 6, so it will share 2. So if this oxygen share 2, carbon will share 2 from that side. If oxygen share 2, carbon will also share 2 from that side. So how many pairs are there? 1, 2, 3, 4. So 4 pairs are there, but it's given 2, so this cannot be an answer. Then CH3OH. So CH3OH means carbon with 3 hydrogen, then oxygen, then hydrogen. So hydrogen share 1, carbon will share 1 from that side. Because we always start sharing from the least number. Then oxygen share 2, 1 is already shared with hydrogen, the other it will share with carbon. So how many electron pairs? 1, 2, 3, 4, 5. So 5 electron pair, but it's written 4, so that's not true. So the correct answer was B, in which there is a sharing of 6 electron pairs. MCQ 16. Which two molecules contain the same number of electrons? Here you have to count the number of electrons. How you will count the number of electrons? You have to use a periodic table for this. If you check chlorine, or Cl2, so when you check that number of electron in chlorine, the atomic number is 17. So if atomic number is 17, the electron number will also be 17 because it's neutral. So how many electrons are there in Cl2? So one chlorine contains 17 electrons. 2 chlorine will contain 17 multiplied by 2, which is equals to 34 electrons. What about sulfur dioxide? So in number of electrons in sulfur dioxide, sulfur is atomic number 16, so it contains 16 electrons, plus oxygen atomic number, not atomic mass, atomic number is 8, so it contains 8 electrons. So this will be 2 multiplied by 8. So when you solve, this is 16 plus 2 multiplied by 8 is also 16, make it 32 electrons. So sulfur dioxide contains 32 and chlorine contains 34, so it cannot be A. When you check B, CH4, carbon atomic number is 6, so 6 electron, plus hydrogen atomic number 1, and there are 4. So total 10 electrons. In water, for atomic number, you have to use a periodic table. I remember the atomic numbers, but you have to use a periodic table. So using a periodic table, you will identify. So the periodic table is given. You just have to identify from periodic table. So here you can see these are the atomic numbers: beryllium, hydrogen, sodium. So carbon, this was atomic number, and this is atomic mass. So we are taking atomic number because we need electron number. So when you find for water H2O, so hydrogen is 1 multiplied by 2 and oxygen is 8 atomic number. How we'll identify? You can see the periodic table. For oxygen, it is 8. So the correct answer here, because carbon is 6 plus 4 hydrogen 10, and water is contain 2 hydrogen and 1 oxygen, so 2 electrons because of hydrogen and 8 electrons because of oxygen, which makes it 10. So B is the correct answer for this. Then question 17 and 18. Potassium bromide and methanol both are compound. Potassium bromide will be ionic compound because metal and non-metal, and methanol CH3OH, which contain non-metal, it will be a covalent compound. Which row is correct? So methanol is a covalent compound. The attractive force between the oppositely charged ions, that's wrong. Why it is wrong? Because methanol is a covalent compound. Covalent compound does not have charge or ions, they have molecules. The attractive force between the molecule is greater than the attractive force between the oppositely charged ions. Then the potassium bromide, the attractive force between oppositely charged ion is greater than attractive force between the molecule. This is a comparison, like because in potassium bromide is a compound, ionic compound, where methanol is a molecule. And in ionic compound, the attractive force between oppositely charged ion is greater than the attractive force between the molecules. So methanol is a molecule and potassium bromide, which is an ionic compound. So these ions have a stronger force as compared to that of molecule. That's correct. That's why potassium bromide is having higher boiling point as compared to. So substance which will have high, first thing how you will identify, you will cancel out the two completely wrong answers. How you cancel out the two wrong answers? Potassium bromide is ionic, methanol is covalent. So definitely ionic compound will have high melting point. So as it will have high melting point, so it cannot be A and B cannot be an answer because high melting point methanol cannot be. So you're left with C or D. Then why the potassium bromide is having high melting point? Because there is a strong force of attraction between the ions, which is greater than the force of attraction between the molecules. And question 18, the formula of ammonia is NH3. Which statement about molecule of ammonia is correct? The bonding in a molecule of ammonia is ionic. That's wrong because it's a two non-metals are there. When two non-metals are there, it should be covalent. Nitrogen atom has a noble gas configuration and hydrogen atom do not. Basically, what happened when you draw the structure, nitrogen share 3 electrons and hydrogen share 1. So all of them have a noble gas configuration. Noble gas configuration means either 8 electron or 2 electron in the outermost shell. So hydrogen is having 2 electron in outermost shell and nitrogen is having 8 electron in the outermost shell. So both have the, because helium having 2 electron, neon, argon, xenon, radon, they all have 8 electron in the outermost shell. So this is a noble gas called a noble gas configuration or complete shell. Nitrogen atoms share all of its electron with hydrogen. Uh, so if you check the statement, nitrogen share all the electron with hydrogen. It's not sharing all. This is one, only 3 shared and 2 unshared are there. And there are 6 shared electron in the molecule. That's correct. This is 2, 4, 6. So 6 shared electrons are there in ammonia. 3 pairs or 6 shared electrons, that's having the same meaning. Is it clear? Anyone else having a doubt in this exercise, ionic bonding? The last one is metallic bonding. Anyone else having a doubt in metallic bonding? Mention the question and the page in which you have doubt. Page 2, question 1 first. The diagram represents a general structure of a solid. What is this? Because this structure shows that it is a lattice of a positive ion and the free delocalized electrons. So means this is the structure of the metal. Iodine is a non-metal. This cannot be an answer. Silicon dioxide, covalent substance, sulfur, a non-metal. So what could be the right answer? A is the right answer because this is the structure of the metal. Metal have a layer or lattice of positive ion and the free electrons. Page 3, question 7. X is solid at room temperature. So substance is solid at room temperature. X is having a high melting point. Solid X conduct electricity. Which diagram show? Look, this one, when you identify the structure, this is a simple covalent or a molecular structure. This one is a structure of giant macromolecular covalent compound. And this is a structure of ionic compound. And this is a structure of the metal. Now you have to check which one having all the properties. High melting point. This is A is having high melting point. B is having high melting point. C is also having high melting point. Conduct solid X conduct electricity. It does not have any free electron, so it does not conduct electricity. This ions can vibrate but not free to move. So in a solid state cannot conduct. So A can conduct electricity. So what could be the answer? A is the right answer. The both properties does not matches with D, so D cannot be an answer. Is it clear? Question 7, page 3, and then page 3, question 9. Metals are malleable. Malleable means you can hammer them into different shapes or sheet. What is the reason why they are malleable? Why they are malleable? Because you can see this is a structure of a metal and these layers can slide over each other without breaking. Means one layer can pass over the other layer without breaking. That's why we call them as malleable. So the answer here, metallic bonding is very strong, but that's not the reason for to be a malleable. This is right, but it's not a reason for malleable. Metals are good conductor of electricity. That's also correct, but this is not the reason why they are malleable. Positive metal ions are arranged in a regular lattice. That's also true, but it's not a reason for malleable. Layers of a positive ion can slide over each other. This is a reason why the metals are malleable. Is it clear? Page 5, question 3. Page 5, question 3. Describe how would you obtain a solid sample of H from a mixture of H and G. So first you have to identify that what is substance H and what is substance G. Substance H, it's a water soluble, basically it's an ionic compound. And substance G, it's a macromolecular covalent compound because it is insoluble, does not conduct electricity. So first one thing is insoluble, another one is soluble, and we have a mixture of G and H. So if we have a mixture of G and H, one dissolve, another one does not dissolve. So first what we will do, first what will happen, we will add water. So when we add water, G will remain insoluble and H will dissolve. So then we will filter. So when we will filter, we remove G from H, but H is in a solution. Then we can either use crystallization or evaporation. So add water. Then filter. And after filtration, use evaporation or crystallization. Is it clear?
Sir,
Yes.
there's a physics sheet which is the graph in motion. You put the marks.
So which statement describes the lattice structure of the metal? The lattice consists of alternate positive and negative ion. That's wrong. Actually, this is not the lattice of a metal. This is a lattice of ionic compound. The lattice consists of neutral atom arranged in a layer. There are no neutral atom. Actually, there is a lattice of a positive ion. The lattice consists of positive ion in a sea of electron. Means there are positive ions and the free electrons. You can see here in the structure. So this is a lattice of a positive ions and the free or the C or the delocalized electrons. The lattice consists of neutral atom. There is no neutral atoms. Actually, this is a positive ion. So C is the correct answer for 10.